Picture the smartest person you have ever met locked alone in a sealed room. No phone, no window. They can reason brilliantly about anything you slide under the door on paper, but they cannot look anything up, cannot press a single button in the real world, and the moment you walk away, they forget you were ever there. Next time you come back, you are a stranger. That, stripped of all the hype, is a raw language model. We spent 2 seasons turning it into something that can act. But to be genuinely useful, an agent needs 2 things that brilliant prisoner does not have: hands to reach a standard set of tools, and a memory that survives until tomorrow. For years, both were a tangle of custom wiring. Then, in just the last 2 years, the whole industry agreed on how to do both. Today, we plug the agent into the world. Both gaps come from the same place, so let us be precise. Remember from Season 2, the model only ever outputs text. So when it wants to use a tool, it cannot reach out and grab it. All it can do is write down a request, a little note that says, "Please run this calculator with these numbers," and hope something on the outside reads the note and runs it. That something on the outside is plumbing we have to build. Now the second gap, the one people miss. The model is stateless. Every time you send it a message, it rereads the whole conversation from scratch, as if for the first time, and keeps nothing once it replies. It has no memory between calls, not because it is broken, but because remembering is simply not part of what it is. So memory, real memory that lasts, is not a thing the model has. It is a thing we build around it. 2 missing organs, hands and memory, and both of them are engineering, not magic. Start with the hands, the tools. Until late 2024, connecting an agent to the outside world was genuinely painful, and the reason is just arithmetic. Say you want your agents to use a calendar, a database, a code repository, a payment system. Every single agent needs a custom connector for every single tool, written by hand, in that tool's own private language. 10 agents, 10 tools, and you are on the hook for 100 bespoke wires. The connectors multiply as fast as you add things, and worse, everyone is brittle. The tool tweaks its interface, the wire snaps, the agent breaks. This is the exact same mess the gadget world lived through for decades. A different charger, a different cable, a different plug for every device in the drawer. Everyone could feel there had to be a better socket. Here is the fix, and it is the same fix that rescued the gadget drawer: a standard socket. In November 2024, Anthropic published an open standard called the Model Context Protocol, MCP, and the analogy everyone reached for, including its own authors, was a USB-C port for AI. Think about what USB-C did. One shape, any device. You stopped buying a special cable for each gadget. You buy the standard and everything fits. MCP is that for tools. A tool is published once behind the standard connector as a small program called a server, and any agent that speaks the standard can use it immediately, with no custom wiring. Write the connector once, and every agent in the world can reach it. That 100-wire tangle collapses into a clean hub. Now, this caught on at a speed that genuinely surprised people. Within months, the other major AI labs adopted the very same standard instead of building rival ones, which competitors almost never do unless the standard is already winning. By late 2025, there were, very roughly, on the order of 10,000 of these servers and tens of millions of downloads a month. And then the real signal that it had become shared infrastructure. In December 2025, Anthropic gave MCP away, handing it to a neutral, vendor-neutral foundation, the same kind of home that already governs much of the internet's shared plumbing, so that no single company, not even the one that invented it, owns it. A standard nobody owns is a standard everybody can build on. Now, if agents can plug into tools through one standard socket, an obvious next question appears. What if the tool an agent needs is another agent? Picture a travel planning agent. It is good at itineraries, but it is not the expert on flight prices or on local weather or on a company's expense rules. Those are other specialists, each its own agent, may be built by a different team in a different framework. You do not want to melt them into one giant brain. You want them to talk. That is the second standard, the mirror image of the first. Where MCP connects an agent to its tools, a protocol called agent-to-agent or A2A lets whole agents talk to each other. Google introduced it in 2025 and just like MCP, soon handed it to a neutral foundation rather than keeping it private. The clever part is how strangers meet without trusting blindly. Each agent publishes what the protocol calls an agent card, a small machine-readable profile that says, "Here is what I am good at, here is how to ask me, and here is how to check it is really me." So one agent can discover another, delegate a task, and get the result back, without either one ever cracking open the other's private memory or inner workings. Notice the clean split. MCP is an agent reaching down to its tools. A2A is an agent reaching across to a peer. One lets an agent use the world, the other lets agents form a team. Together, that is the nervous system of a world made of cooperating agents. Now the second missing organ. The agent can reach tools and reach other agents, but it still wakes up every morning a stranger. So how do you give a stateless thing a memory? You build one deliberately in layers. The first layer is short-term memory and you have already met it. It is just the current conversation sitting in the context window, the model's working scratchpad. Useful, but the instant the session ends, it is gone, like a whiteboard wiped at the end of a meeting. The second layer is long-term memory, an external store that actually persists, a notebook that survives between visits. And building that notebook well is real engineering because you cannot just save everything. The system has two hard jobs. First, extraction, deciding what was even worth keeping. A lasting preference, yes. An offhand remark, probably not. Second, and this is the subtle one, conflict resolution. Last month you said you were vegetarian. Today you order chicken. A good memory does not pile both facts in a heap and get confused. It notices the contradiction and updates, the way a thoughtful friend would. To keep the kind straight, the field borrows three names from how human memory is studied. Episodic, the specific things that happened, like what you and the agent worked on last Tuesday. Semantic, the durable facts like your name, your job, your preferences. And procedural, the learned how-to, the routines and patterns the agent gets better at with practice. None of these live in the model. Every one of them is scaffolding we build around it. But now a real problem bites. That long-term notebook can grow huge, an entire history with a user, thousands of pages. And the context window, the model's working desk, is small and fixed. You physically cannot lay the whole notebook on the desk at once. So how do you let an agent feel like it remembers everything, when it can only ever hold a few pages in front of it? The answer is one of my favorite ideas in this whole field, and it is borrowed straight from how a computer's operating system works. Your laptop pretends it has far more memory than it physically does. It keeps what you are using right now in fast memory, and quietly shuffles everything else off to the slow disk, paging the right pages back the instant you need them. You never notice. A landmark project called MemGPT applied that exact trick to an agent. Treat the small context window as fast memory, the big external store as the disk, and let the agent itself decide what to swap. When something old becomes relevant, page it back onto the desk. When the desk gets crowded, file the least needed pages away. The agent does not actually hold an infinite memory. It just manages a small one so well that from the outside it feels limitless. The model is a small desk. Good engineering makes it feel like a vast library. Step back and you can see the discipline this all adds up to, the one that got a name in 2025. It is called context engineering, and here is the cleanest way to hold it. The context window is not memory. It is a small, precious budget, and every token you spend on one thing is a token you cannot spend on another. So the whole craft is deciding, for this exact moment, what deserves a seat at the table. Practitioners frame it as 4 moves. Write, save things outside the window for later. Select, pull back only the few pieces that matter right now. Compress, boil a long history down to a summary that still fits. and split the work across separate agents so no single window gets overwhelmed, which kills the most tempting misconception in this whole space. People assume a bigger context window is the same as memory. It is not, for two separate reasons. First, the window is volatile. It still gets wiped between sessions, so a million token disk you cannot save is not a memory. It is a very large whiteboard. Second, and less obvious, a fuller window can make the model perform worse, not better. Researchers have a name for it: context rot. Pile too much in and the model tends to lock onto whatever is at the very start and the very end and lose the crucial detail buried in the middle. So stuffing everything in is not just wasteful, it can actively hurt. Memory is something else entirely. It is the persistent library you save to and read back from, plus the discipline of choosing what to carry. The desk, however large, is never the library. And one honest warning before we go. That beautiful standard socket we celebrated, the one that lets any tool plug into any agent, is also a standard front door. A tool's description, or the data it hands back, can carry hidden instructions the agent reads as if they came from you, quietly turning your own helper against you. The very standardization that made agents powerful made them attackable in a standard way too. We will not show you how that attack works here. We will spend an entire episode on defending against it. Because once you give a brilliant, trusting mind both hands and a memory, the question is no longer just what it can do. It is who, exactly, gets to whisper in its ear.